Labels. Okay, so we're going to put the pullback distance on the x-axis. What are we going to put on the y-axis? Distance traveled. And does it make sense in this particular case? Does it make sense for the x to be the pullback distance and the y to be the distance traveled? And if so, why? If not, why not?
Doesn't this depend on pullback?
Yeah, the whole idea is in this particular case, we were changing the different pullback distances. And so we have a very, very clear, I'm going to call them explanatory and response variables. In your guys' heads, you can think of them as independent and dependent variables. Okay? So, and then I'm just going to make a scale. Your goal when you're building a scatter plot should always be to try to, one, you need a scale, but also you want to fill up as much space as possible. Graphs tell us more information when we are, quote unquote, zoomed in on them, okay? All right, does my X scale need to match my Y scale? Because if so, we have a problem, don't we? Okay, so let's see. I'm going to count by 20s. A 100 is going to be a little bit above the graph, but when we go to plot that point, it'll be okay. All right? And then we just plot our points. 222. 450. That one was kind of crazy that it was nice and even, but it was. 675. All right, so right now on this scatter plot, what do you see?
A positive slope.
Positive slope, okay. And for right now, I'm going to call that a positive relationship. And that as the pullback distance increased, so does the... Anything else jump out at you? Yeah, Griffin?
It kind of like, it goes up kind of a lot, then it kind of hits this point where it's kind of like diminishing returns to where you just don't get as much.
Yeah, for sure. It seems to be, if I look at this right-hand side of the graph, it kind of feels like it's leveling off a little bit. And like, as you guys were playing with them in general, do you notice that you kind of get to a place, I think these are all the broken ones, but that click, oh, not broken. That's kind of where we can see like where it would start to fall off. Okay? All right? What else? Does it appear to be a direct relationship? Direct would not just be that it increases, though also for direct relationships it's supposed to increase at the same rate, but also 0, 0. What do you guys think about 0, 0 here?
If you don't pull it back at all, then it won't go forward at all.
Yes, but if I pull it back even like a little tiny bit, sometimes it doesn't either. Like there's like, and like as... And Savina, you're going to be the one that can hear this. Did you hear that the wheel spun just a little bit? When I pull it back just a little bit, it's like there's like this moment it needs before it'll go. Like it, because it's got to have enough force that it kind of pushes it a little bit to get it started. All right. So technically, this is not going to be a direct relationship. Okay. So Last unit, we only focused on a y-intercept of 0. This unit, we're going to add in this idea that not all linear relationships are direct. Okay. So if we're going to be dealing with lines, let's do a quick review of linear equations. Okay, so a linear equation. What form does a linear equation take? Y equals mx plus b, where m is the slope and b is the all right. So if I ask you what is the equation of a line that has a slope of 2 and a y-intercept of 5, the answer is
y equals 2 plus 5.
y equals 2x plus 5. All right. But now if I say it has a slope of 5 and passes through the point 27, is the point 27 a y-intercept? How do I know it? Like, what's true of all y-intercepts?
You have a y of 0.
They do not have a y of 0.
X is 0.
X of 0. So in this case, x is not equal to 0. This is not the intercept. Okay? We have to find the intercept. Everybody good? All right. I can't remember if I taught this to some of you guys, most of you guys last year at all. But we're going to talk about a different form of the equation of a line. It is called point-slope form.
I think we did talk about.
We did talk about point-slope form. For some reason, I feel like I might have taught it with one group, but not the other. I can't remember. Point-slope form of a line looks like this. All right, and basically the x and the y, notice that when we have a linear equation, we leave an x and a y in our equation, okay? And that x and the y in the equation are all the different points on the line. The same with this x and this y. Well, I underlined those backwards, right? I underlined the y when I said x. Okay, but those x's and those y's are the general any point on the equation. The x1 and the y1, those are the x's and y's from our specific point. Okay, so y minus y1 is now going to become y minus 7. What's my slope? 5. X minus x1 is going to be x minus 2. And if I ask you for the equation of a line in point-slope form, this is what it would look like. So this is point-slope form. Now, that y equals mx plus b is what we call slope-intercept form. So you guys, I know it doesn't kind of say this over there, you guys are going to have a graded assignment tomorrow because I'm going on the theater field trip. I'm one of the chaperones for the / van drivers for the theater field trip. So you guys are going to have a graded assignment. Mr. Whelan will be here, and I'm going to ask you sometimes to put your answers in point-slope form and sometimes in slope-intercept form. So I'm going to expect you to know the difference. Okay? All right. If I gave you this equation, though, could we turn this into y equals mx plus b?
Sure.
Relatively quickly. What would I do first? Distribute. I get y minus 7 equals 5x minus 10. So y equals 5x minus 3. Everybody good? All right, so I'm going to start with, can you put this one into point slope form? What do we remember about parallel lines? They have to have the same slope. What's the slope of this line? 3. So what's the slope of something parallel to it? 3. So go ahead and do that point slope form for me real quick. That won't be the first time you find some over that. How'd we do? Do we all catch that negative? Minus y minus negative 1 would be y plus 1. Minus a negative is a positive. Yeah? All right, what if I then asked you to put this into slope intercept? What are we getting?
Y equals x minus 5.
I'm sorry?
Y equals x minus 5.
Remember, our slope is 3, yeah? So you would distribute that 3?
Oh, yeah, I forgot about that.
Yeah?
Y equals 3x minus 13.
Y equals 3x minus 13, I like. Everybody good? All right, what about this one?
Isn't perpendicular like the opposite slope?
Not opposite. It's opposite and
Negative.
opposite and negative mean the same thing, y'all. It's the opposite reciprocal. Okay? So, what does reciprocal mean? Flip. Okay. So, what will the slope of my line be if it is perpendicular to this line? Negative 1 over 4. So, if it's perpendicular, the slope is going to get flipped upside down. So, this is, and it's going to change sign. Okay? Everybody good? All right, go ahead and find me the point slope form. Bless you. How'd we do? And what does that make my...
Y equals negative 1/4 x plus 1/4 plus 7/4.
Plus 7/4. Theo, when you distribute this negative 1/4, it's a negative times a negative would be plus 3/4. Was I right? In terms of what you...
Yeah.
Mm-hmm. All right.
Was that 740?
Yes. Thoughts?
A little bit scary.
A little bit scary?
Yeah, not too much.
No, it's not that bad.
All we need to do is find the equation, yeah? What do we need in order to write the equation?
Random set of points on the line.
Not even a set of, we need,
The y-intercept?
maybe. It depends. How do we want to write the equation? Do we want to do point slope form, slope intercept form? We got lots of things that we could do here. Okay? So, for instance, I say, since we have the y-intercept, that's a nice easy point to figure out, right? Does anybody know what the slope is?
1.5 over 1.
2 over 3?
Okay, remember, slope is change in y over change in x. Here's my change in y is describing the up and down motion is 2. My right-left motion is 3.
Wait, it goes negative 4, negative 6. Wouldn't that only be 1, not 2?
This is negative 5.
How do you go from negative 5 to negative 4 and 2?
But this is, I see what you're saying. If I use two coordinate pairs where we have the full set of points, this is going up. All right. What about this one? Is the y-intercept an easy point to use here?
No.
No, so don't use it. Does anybody see a nice easy point that this line goes through?
4 and 7.
Okay. The point 47, cool.
And then 5, 1.
I don't think you mean 5-1.
1.5?
I think you mean 1-5. All right.
Which one's y1?
Doesn't matter. So we could do, for instance, y minus 7. What's my slope here, y'all?
2/3.
All right, so y minus 7 equals 2/3 minus times x minus 4. Or I could do y minus 5 equals 2/3 times x minus 1. Cool? And if I put those, either of those in slope-intercept form, let's see, for this one I'm going to get y minus 7 equals 2/3 x minus 8/3, and then I'm going to add 7. And let's see, y equals, let's see, 7 is 21/3. 21 minus 8 is positive 13 over 3, which is 4 1/3. Everybody good? And if I did that exact same thing here, I get y minus 5 equals 2/3 x minus 2/3. And let's see. Oh my gosh, guys, I feel like I'm getting the exact same answer.
Yeah.
And if I look at my graph, how do you guys feel about my y-intercept being 4 1/3? Does that feel like, doesn't that look about right?
Yeah.
Okay, I would like you guys to do one more thing. Here's that exact same data where I drew the scatter plot for you using tech, okay, or using Desmos. Independently, I want you to sketch in a line of fit. And as you do that, you're going to want to pick it so that it goes right through like one of the lines. What you think, so like you guys with me here? Like right through one of those crosshairs. So that you can end up with 2 easy coordinate pairs. Is everybody with me? Start there.
There's one of the dots where I don't know if it falls on the.
So just sketch in what you think could be a best fitting line. That's all I want you to do. It's not going, I promise you, because of the way I'm asking you to do this, you're not going to have the best fitting line. You're going to have something close. That's all I want you to do is find something close. It's a lot easier for, whoa. I'm kind of cheating a little bit. All right. Guys, what do you guys think about my line? I don't think it's very good.
I think it could be better.
You think it could be better?
Yeah.
What do you think I need to do?
Rotate it like kind of this way a little bit. Say yeah.
Like this?
Yeah.
Does the alignment
I'd say right there.
originate from 0?
No, it does not need to originate from 0. Because we said there's probably at least a little bit of like, even if I pull back a little bit of distance, that it needs to get past that like first thing to shift it, get past its weight. So it needs a little of initial force that it has, okay? All right, so here's what I want us to do next, and then On Monday, we'll work with this piece a whole lot more. Okay? So tomorrow you're gonna have a graded assignment that might include drawing a scatter plot. That will definitely include some stuff that includes equations of lines using y equals mx plus b or point slope form. Okay? All right. So so we each should have a slightly different line, yes? All right. What I want you guys to do on your line is just find some places where it crosses. Like I'm picking this one. And do you guys see that in this point, my line is making a nice, easy, it's going through those crosshairs that makes it really easy to determine where it is. Okay? And then I'm going to pick another one, like this one, right here. And so, like, for instance, I can see that this is the point 8, 80, and then this one's the point 4, 45. Do you guys see what I'm saying there?
Yeah.
And you go ahead and find your own 2 points for this.
Miss Meister, I did some points before you did yours, and I did 4.
That's fine, because you have a different line than me.
Yeah.
Oh, but yours also goes through 445. Okay. All right. Now, the next thing I'm going to have us do once we find our 2 point shell, go ahead and calculate the slope between these 2 points. Now, we have to be really, really careful. Okay? Can I just count from this point to this point and say I went up 1, 2, 3, 4, 5, 6, 7? Can I just do that?
No.
Because it didn't go up 7. You with me? It went up by a lot more than 7. It went from 45 to 80. It went up by 35. Do you guys see what I'm saying here? Okay? And likewise, it didn't go over by 20. It went over by 4. So you want to make sure like you're considering the fact that the scales aren't the same. So when I measure this distance for mine, this is plus 35, and this is plus 4, and we can see for sure those scales are super different from each other. And it would need to be because this isn't like nice round numbers. This is real data that we gathered. Is this okay? All right. Now, once you have your point, so I can tell that my slope is 35 over 4. And then I'm going to use the point 445. You're going to use one of the 2 points that your line goes through, okay? And can you go ahead and find the slope-intercept form of your line? I'm going to find the slope-intercept form of my line. Slope-intercept is the mx plus b, y'all. Okay? But if I were you, and this is how Miss Meister always does this, I'm going to find the point slope form first and then use that to find my slope intercept form. Now, how many of you have the exact same equation as me? By the way, if I do 35 over 4, that works out about to be 8.75x plus 10. How many of you have an equation close? Similar slopes, similar y-intercepts. Yeah. What was yours? And what is your y-intercept?
12
12 and
and a half.
a half, not that far from 10. Yeah, Cody.
I have a slope of 10 and a y-intercept of 5.
You guys with me? Now, is it true that one of us did better than the rest of us?
Yes.
Probably. It's subjective, but yes.
You think it's subjective?
Yeah.
I don't think it's
I
subjective.
think math can be objective.
Subjective? Oh, math can absolutely be subjective.
What about objective?
You guys think it's objective. It is very subjective.
It has a lot of subjects in it.
1 plus 1 equals 1. That's fact. You can't argue it.
I can argue whatever I want.
2 plus 2 equals 5.
Do you want a proof for that?
No, I hate proofs.
I can show you a proof for 2 plus 2 equals 5.
Oh.
It exists. It doesn't make it right.
I would like to see it.
Statistics very frequently is subjective. But that's a top discussion for another day. Okay, so on Monday, we are going to look at these and see whose average prediction error, just like we did in the last one, whose average prediction error was the best. That's one of the ways we can measure. What was your line?
I don't know what I did wrong, but it was not even close.
Miss Meister?
Not like what was it?
I don't know because I'm looking at it and I'm like.